So now let's get back into our right triangle trig and see some special right triangles. 30, 60, 90, and 45, 45, 90 triangles are going to be the basis for so many operations we do this year. So we should be able to derive the 6 trig functions for 45 degrees, 30, and 60. So let's look at this first example. Here we have a 45, 45, 90 triangle. If these two angles are equal, it's an isosceles triangle. So that means the ratio of these sides are 1 to 1. So if I'm trying to look for my hypotenuse, I can use the Pythagorean theorem, the square root of 1 squared plus 1 squared. So my hypotenuse is the square root of 2. These ratios are always true in a 45, 45, 90 triangle. Now let's focus on this angle as my reference angle. That means that this 1 is opposite, this 1 is adjacent, and my hypotenuse is square root 2. So now let's do our 6 trig functions. Sine of 45 degrees is opposite over hypotenuse. Rationalize that denominator, square root 2 over 2. Cosine 45 degrees is adjacent over hypotenuse. Rationalize that denominator, square root 2 over 2. And tangent 45 degrees is opposite over adjacent, 1. So let's do those reciprocal trig functions. Cosecant 45 degrees is the reciprocal of sine, square root 2. Secant 45 degrees is the reciprocal of cosine, square root 2. And cotangent of 45 degrees is the reciprocal of tangent, 1. So these trig ratios you ultimately do want to memorize. But if you don't memorize them, you can always derive them.